Hey everybody, in this video I am going to be doing example 1 of several different examples in a series of videos dealing with related rates. So in this problem we've got a point that moves along a cubic function, and we're being asked that if x is increasing at a particular rate, then how fast is the other quantity, y, increasing at a particular point on the curve. So the general approach to questions like this is you start off with the equation that relates the two quantities, in this case y and x, okay? And that's simply y equals x cubed minus 3x. And then what you want to do is take the derivative of this equation so that you know how and remember the derivative really means the rate of change, right? So if you take the derivative of this equation, then you will know how the change in y, or the rate of change of y, relates to the rate of change in x. Okay, so let me give you an example of what I mean. Normally what we would do is, when we're asked to take the derivative of this, we would automatically assume that we're taking the derivative with respect to x, right? So you would go dy dx, and then you would go 3x squared, because that's the derivative of x cubed minus 3, and then you'd be done, okay? But we don't do that for questions like this because we're not actually given anything, nor are we asked to provide any sort of rate of change of y with respect to x. Instead, we're given the rate of change of x per unit time. So it's not dy dx, it's dy dt. And we're being asked to determine, I'm sorry, this actually is dx dt, right? The rate of change of x. We're being asked to determine dy dt. Okay, so this is actually the wrong approach. The right approach is to take the derivative of both x and y with respect to time. So the derivative of y with respect to time is just dy dt. The derivative of x cubed is 3x squared, but then chain rule would have us go in and take the derivative of x, right, with respect to time, right? Normally we're not used to this because if we go in and take the derivative of x, it's just 1. But that's when we're taking the derivative with respect to x. We're now taking the derivative with respect to time. Okay, similarly over here, the derivative of negative 3x is negative 3, but then chain rule has us go in and multiply by the derivative of x with respect to t. Okay, so that's it. So now we start with an equation that relates x and y. Now we have an equation that relates the rate of change of x to the rate of change of y. So what we're looking for is dy dt when x equals 3. Okay, so I can start subbing things in. When x equals 3, I'll just sub in x equals 3. dx dt is really this, okay? This is really dx dt. It tells us x is increasing at a rate of 6 units per second. Change in x related to time, or per unit time. So this would be times 6 minus 3 times 6. Okay, and so I end up with, what would this be? This would be 81 times 2, which would be 162, minus 18 is equal to 144. Units would be, so y, I guess would be units per second. Okay, and it's really as simple as that. I mean, I took my time explaining how to do this, but you start with an equation that relates the two quantities. You take the derivative of both sides of that equation with respect to time, and then you sub in the appropriate values to get your final answer.